Hello everyone, welcome to Pepcoding. So in this video we are going to discuss the question that is even odd tree. So what is the even odd tree? A binary tree is named as even out if it meets the following conditions. So what are those conditions? The root of the binary tree is at level index 0. So the root will be at level index 0. So, and its children are at level index 1, and its children of root are at level index 1, and their children are at level index 2, and their children are at level index 3. So, like this level order goes on. So, now second point is for every even indexed level. So, what are even indexed level? These are even indexed level. So, at every even indexed level, all nodes at the level have odd integer values. Means at even indexed level, all the nodes means nodes present at that even level have odd integer values. Means these values are integer values. Okay. And that too in strictly increasing order from left to right. And that also must be in strictly increasing order. Strictly, what does strictly increasing means if first node is 3, then the next node from left to right must be greater than 3. Suppose if this is 3 and this is also 3, then this doesn't follow the strictly increasing order. Means this next value must be greater than 3. So this is what strictly increasing means, and that too must be in left to right order. So for this particular tree, the values present at even level are odd values, odd integers, and that too are in strictly increasing order. Okay, so this tree is fulfilling this condition. Now talking about next point. Okay, so for odd index level means these odd indexed level, all the nodes at the level have integer values. So these nodes must have even integer values. So these nodes must be even integers. Okay, and that too must be in strictly decreasing order. And these even values at odd level, odd level must have even values. And even level must have odd values. And that for odd index value, for odd indexed level, the nodes must have even integer values. Okay, and that too must be in decreasing order. So that must be in decreasing order. Okay, decreasing order, and this should be in strictly increasing order. So this particular binary tree is fulfilling all these conditions. So this will be a even odd tree. So let's take another example. Suppose this is a tree. This is 5. Okay, and this is 4. This is 2, and next level is having 3, 3, 7. If we'll check this condition, these are the level. We'll check for this whether this tree is an even or true tree or not. So level is even. For even level, all the nodes must have odd integers. So is it having odd integers? Yes, it is having odd integers, and must be in strictly increasing order. So this is in a strictly increasing order. This is correct. Is this in a strictly increasing order? So this is not an strictly increasing. Why? This is increasing but not strictly increasing. Why? Because this node is not greater than this node. This is equal. So this is not following the strictly increasing order. So this tree, this whole tree will return false. So it will conclude that this tree is not a even odd tree. Let's take another example. Suppose this is a tree 5, 9, 1, 3, 5 and 7. So this is level 0, 1, 2. So for for even for even level for even level the values must be odd. So this is following this thing. For even index level, nodes must be odd integer value. So this is following this, and that too must be in increasing order. So is this in increasing order? Yes. Is this in strictly increasing order? Yes. Now we'll check second point. For odd index level, the values must be even integer. So is this an even integer? No, this is not even integer. So this whole tree is not a even odd. This is also not an even odd. Okay. So this thing we have discussed. Now we'll discuss about the its approach to solve this question. So what we'll do, I hope till now you have understood the question. Now we'll discuss the approach for its solution. So let us write some points that even level must have odd integers, okay, and odd level must have even integers, strictly increasing, and that too in strictly decreasing. Okay, so now what we'll do is we'll firstly figure out the height of the binary tree. Using the height, we can identify the number of levels present in our tree. Suppose this has the height of this binary tree. See, we'll be writing all the points. So for this binary tree, firstly what we'll do, we'll find the height of binary tree. For this particular binary tree, the height will be 1, 2, 3 and 4. So this height will be 4. So now what we'll do, see, the first thing is we have to check the level. If the level is even, we will simply check the values. If the values are, for even level, if the values are odd, then it is satisfying a condition. For odd level, if the values are even, then it is satisfying the condition. So we will check this thing in pre-order. In pre-order, we will check this thing, calling its left child and right child line by line. We will put the condition for checking the level, and then we will put a more condition inside if condition, and we'll check whether this value of root is even or odd. For even, it must be odd. We'll check for the false condition, and we'll find our answer whether this is correct or not. But the case will be more tricky when we have to check whether at this particular level all the values are in increasing or not, and at this particular level we have to check all the values are in strictly decreasing order or not. So for this, what we'll do, we'll create an array. We'll name that array as pre-data, and this will be of size height. So this will be at 0 index, at 1 index, at 2 index and 3 index. So initially at 0 level, means at even level, we have to find the increasing order. We have to find the increasing order. So what we'll do, we'll compare the value with minus infinity, that is minimum value, because we have to find the increasing order. And at odd levels, we have to find the strictly decreasing order. At odd levels, we have to find the strictly decreasing order. So we will initialize the odd levels with infinity. And what we'll do, we'll update while coming to levels, we'll update these values. So second point will be, we'll initialize the pre-data array of size, height, and at pre-data of even level, we'll give minimum value, and at pre-data of odd, we'll give maximum value. And then what we'll do, we will, so for finding height of binary tree, we will also make a function, height function, and using that function we will find the height of binary tree. So this is first step, this is second step. Now in third step, what we'll do, we'll check line by line the level. We'll check the level. If level is even, suppose the level is even, so for even level the value must be odd. The value must be odd for even level. So what we'll check, we'll check for false condition. See, we are not checking for true condition, we are ultimately at every step we are checking for false condition. If any of this condition will receive false value, we'll simply return the false value from the whole function. Means for getting true answer, that for becoming whole tree as even odd tree, everything must return true. If any of the condition, any of the case become false, then the our whole answer will become false, means the tree is not a even odd tree. So we'll check for false conditions basically. So if the level is even, what we'll check, the r value must be odd, so we will check for even condition, even value. If value of root, if root value is even, means we are checking for false condition. If level is even and if root value is even, so we'll return false. Okay, and the next condition will be, we'll also check that it is in strictly increasing order or not. So for that, what we'll check, we'll check for the false condition, that is if this value stored is greater than, means this value is greater than this value. See, if value at pre-data is greater than or equal to value at this, means that root value. If this is greater than or equal to root value, then it will return false. See, once again see this condition. See, we'll check at this level. For second level, level is even, okay, value of root is even, value of root is even, no, value is not even. So we will check another condition, that is pre-data value must be greater than, if pre-data value is greater than or equal to root value. So here root value is 3. If this minus infinity is greater than or equal to 3, then it will surely return false, means this is not in strictly increasing order. And then what we'll do, we will, so this will not get trapped into this condition because our pre-data value is less than, pre-data value is less than root value. So we will not get trapped into this condition. And then what we'll do, we will make pre-data value equal to root value, means for the next call, means when we'll again get trapped into this level, then what will happen, then for the next time this value will become 3. Now we will compare, when we'll come at 7, we'll compare this 7 with 3. Okay, we'll compare this 7 with 3. So 3 must, if 3 is greater than equals to 7, means this is not in strictly increasing order. If now this time pre-data value is containing 3, if this 3 is greater than or equal to 7, means this is not following strictly increasing order. So if 3 is greater than equals to 7, it means this is following strictly increasing order, and we are checking for the false condition. If anyhow we get the condition, suppose here it is 6, so what will happen for the next time? It will become 7, and we'll check if 7 is greater than equals to 6, then it will become true. And when, as soon as this condition becomes true, it will return false, because 7 is greater than equals to 6, and this will break the condition of strictly increasing. So this is what I am trying to explain over here. So then again we'll check the same thing for if level equals to odd. If level equals to odd, we'll check the condition. If root value is, for odd level, the root value must be even, and if it is also odd, then return false. Basically we are checking for false condition. And at last what we'll do, we'll return whatever we will get from our left and right. If either of left and right is false, then we'll simply return false. How? We'll call our function recursively, that is check even odd, and we'll pass left, increasing the level, and we'll put the and condition. We'll call check root dot right, and we'll increase level. So whatever are this function will return, this is left call and this is right call. If either of this call becomes false, then it will simply return false. And as long as this is returning true, we will be making the recursive call again and again. Okay, so let us code for this approach, then we will be getting more clearly what we were doing over here. So this is our is even odd function, and our very first step was to create a function of height, which was returning height of the tree, and using that height we were creating an array of pre-data. So in this function we will basically find the height of our tree, passing the root, we will be not discussing this height function because this is another concept, and this function will return height of the tree. So height from left, and height from right, and maximum height from left and right plus 1. So this will return the height of the binary tree. And our next step was to create a pre-data, of height, of size height. So this is our is even odd function. We'll call our function height, and we'll extract the height. Now we will take a static variable pre-data, this pre-data must be of size height. So new int height. And what we'll be doing? We'll be starting a loop from 0 to less than height, and in even case we'll be initializing with minimum value, and at odd level we'll be initializing with maximum value. So we'll start a loop from I equals to 0 till I less than height, and if this I is even, we will initialize with minimum value. So value, and in else part we'll initialize with maximum value. If the level is odd, then initialize with maximum value. So till here we have created our array. Now we will return whatever answer we'll get from our check function. We'll pass root and a level. Initially the level will be 0. So now we'll create the function. This will be Boolean type. Function is check. This will be level. Base condition, if root equals to null, return true. Otherwise, we'll firstly check the condition. So our first step was we are checking the level. If the level is even, we were checking. If the value is also even, then return false. And if it is not following the strictly increasing order for even levels, if it was not following the strictly increasing order, we were returning false, and then we were updating our pre-data values. So we'll implement this thing. So firstly we'll check the level. If level mod 2 equals to 0, it means if the level is even, we'll check the condition whether value must be odd. For even level the value must be odd, and we are checking the false condition. If this will be false, if value is even, then it will return false. For even level the value must be odd. That is why we are checking for the false condition. Now we will check for whether it is strictly increasing or not. So we'll compare with value is stored in pre-data, level index will be level. If the value stored as pre-data is greater than or equals to value of root, then it means it is not following strictly increasing order, so we will return false. If none of these conditions is true, then we will do what? We'll update our pre-data value. Level will be updated by value of root. Similarly, we'll check for else part, that is if level is even. So for that is if level is odd. So what we'll check? If the value value for odd level, if the value is odd, then it will return false, and if it is not following strictly decreasing order, then it will return false, or otherwise data will be updated. And now whatever we'll receive from left and right call, we'll take AND of it and we'll return its answer. So we will call for left, increasing the level, and we'll check for right side, increasing the level, so whatever we'll receive from left and right, if either of this returns false, then ultimately our whole answer will become false and we will return false, and this false will received by this check function, and from here our answer will get returned. So let us discuss once more. See, first we have found the height and we have called the height function, and of the size height we have created the array of pre-data, and at even level of pre-data, even index of pre-data, we have stored the minimum value, because at even level we were finding the strictly increasing order. So for finding increasing, the first value must be minimum value. Okay, so now for at odd indexing, we'll initialize with maximum value. Now we will call the function check. We'll pass the root value and the level. So this is the base condition, and we'll check the level. If the level is even and the value also becomes even, so this means it is not an even odd tree. And for the even level, if it is not following a strictly increasing order, we'll return false. And if it will not get trapped in any of these conditions, we'll update the value of pre-data. That is, we were updating over here. Updated by 3, updated by 7, like this. Similarly, like infinity, it will updated by 12, then 8, then 6, like this. Okay. Same thing we are doing for if level is odd, and if calling for left and right, increasing the level. If any of this condition become false, it will ultimately return false. So I hope you have understood this thing. Now we'll run our code, since there is work going on in backend side. So there are the test cases are not uploaded yet. So if you'll run this code, it will throw some error. So for now, what we'll do, see, it is giving exception because still the test cases are not uploaded. So by the time you will reach here, that you will be able to run the code, because at that time test cases will get uploaded. So for now, what we'll do, we'll give custom input of the tree for which we have discussed the approach for this tree. For this whole tree, we will be given custom input. So the input is prepared. So we will give this input to check whether it will return true or false. So let us run this. So it is giving value true. And while explanation also, we have found that this tree was even odd tree. Okay, because it was fulfilling all these three conditions. It was fulfilling all these three conditions. Okay, so I hope you have understood the question and the solution. So thank you for watching. We'll be meeting in another video with another question.